Welcome to Vision Plus and welcome back to Decimal Form Mathematics. We are looking at equation of the tangent. Example 3, part A says, find the equation of the tangent to the circle x squared plus y squared equals 5 at the point -2 and 1. So method 1 is the method of the gradient function. So part A, given as x squared plus y squared equals to 5 at the point of tangency -2 and 1. If you are using the method of the gradient function, it is not important for you to sketch the circle. What is very important is that you must know that the given point is the point of tangency. This is the point of tangency. What does it mean? This is the point at which the tangent touches the circle. That is what you must keep in your mind. So what do we do here? We come and differentiate the circle. So we're going to differentiate both sides. So d dx of the function x squared plus y squared equals to d dx of 5. Differentiate the left hand side and also differentiate the right hand side with respect to x. What do we do here? If we differentiate x squared, we get 2x. It is a function in x, so we say dx. But with respect to x, so dx plus, if we differentiate y squared, we get to y. It is a function in y, so we say dy. But with respect to x, so we say dx equals to, if we differentiate 5 is a constant, we get 0. Any constant that you differentiate, you get 0. Now from here, this dx and this dx are cancelling out, so that here we have 2x plus 2y dy dx equals to 0. But the method of gradient function means we are looking for dy dx. So from here, let us make dy dx the subject of the formula. That means here, I'm going to carry 2x that side, so that here I'm left with 2y dy dx equals to -2x. But I'm making dy dx the subject. That means, therefore, dy dx equals to -2x out of 2y. It's just a matter of dividing both sides by 2y, and then you arrive at that expression. Now from here, what do you see? Here we can simplify. 2 and 2 are going, so that we have -x out of y. This is the gradient function of the circle. What is the meaning of the gradient function of the circle? The gradient function, gives us the gradient of the circle at any point on the circumference. So this function applies anywhere on the circumference of the circle. That means it also applies to the point of tangency, because the point of tangency is on the circumference. It is the point on the circumference where the tangent meets the circle. So we're going to say, for us to get the gradient of the circle at the point of tangency, we need to substitute for this point on the gradient function. So that we now say at the point of tangency -2 and 1, it now means that dy dx at that point of -2 and 1 becomes, remember this is x, this is y, so we substitute for them here. What is x? X is -2. x is negative 2, which we are seeing here. So we'll open the bracket, and then I will say x, there is a negative already, negative, then open the bracket. What is x? X is negative 2 out of y. What is y? Y is 1. This here gives us 2. Okay, now this 2 is the gradient of the circle at the point of tangency. And we know that at the point of tangency, the gradient of the circle is the same as the gradient of the tangent. So if this is the gradient of the circle at the point of tangency, it implies that it is also the same gradient of the tangent at that point. Therefore, gradient of the tangent is 2. Now, since we know the gradient of the tangent and we know this point on the tangent, this point is being shared by the circle and the tangent. So the equation of the tangent thus becomes what do we know? We know the point of tangency, which is negative 2 and 1. And then we also know the gradient of the tangent, which is n. I'm going to call it n, which is 2. Now, we know that a tangent is a line. So from y equals mx plus c, we have x here, we have y, and we have n. So we can find c, where c is the y-intercept. So we substitute 1 equals n is 2, and x is negative 2 plus c. When we make c the subject, we find that c equals to 5. After getting c, then we substitute for n and c so that we can get the equation of the tangent. Therefore, y becomes, what is n? n is 2, x plus c, plus c equals c is 5. We only substitute for n and c, but we leave y and x because this is the equation of the tangent at any point on the tangent. So this is the solution to part A using method 1, that is the method of the gradient function.